Use synthetic division to evaluate the polynomial functions. So use the synthetic division to find the p of -2 when you have polynomial function is a degree power 3 function. So we just simply substitute x equal -2 into here and do the same process to replace each of the x term from the function in the function. So when we do the calculation, the outcome here tell us when x equal -2, it will has a remainder. So that means -2 is not a root of this polynomial function because it has a remainder. So with this type of the test or check whether the solution is a root or not of the polynomial function, this is a fast way you can get the right solution. Okay, so that means when x equals -2, the outcome is 13, and 13 is a remainder. Use the synthetic division to solve the polynomial equations. Whether the polynomial equation is this one, completely to solve the polynomial equation, we set that equals 0, and given that 2 is one solution. So this 2, it tells us it's a solution. That means 2 is the root of this polynomial. So since we know 2 is a root already, we can start from this 2 to break down the function into small pieces. So from there, we can solve for x. Now I'm going to use this synthetic division to break down the function into small pieces by using the rule is 2. So the way I compute the work, I write down the numerical term of the polynomial function. So we have 3x squared minus 5x squared, this is x power 3, plus 3x, and the number term, constant term is -10, so this will be x power 0. It gives us 2 is a root, so we put a 2 outside. And keep in mind, this is a root. When I reflect the root back to the factor form, you should make the change of the 2 turn to the -2. So the factor form is x minus 2. Let me rewrite here. X minus 2 is a factor form. So 2 is a root. Okay, but these 2, they carry the same meaning. Now we solve for this one by using the synthetic division. I jot down the 3. Now 3 multiplied with 2 is a 6. Sum these 2, you get a 1. Now multiply 1 with the 2. So you get a 2. Sum these 2, you get a 5. Multiply 5 with a 2, you get a 10. Now sum these 2, you get a 0. Now we interpret the other 3. What do they mean of these 3? This is a constant term. This is an x term. This is an x squared term. So if I rewrite the solution back to the function part, we can write down the p of x is equal x minus 2 because this is one root, right? 2 is a solution. Like they give us this solution at the first beginning. The other 3, I will have 3x squared plus x plus 5. So from the first factor form here, we know x equals 2, so we can solve for x. But here we have trinomial, so we need to continue to do the factoring to solve for x. When I have 3x squared plus x plus 5, finding the factor form of these 3, when we have the chapter 1, I told you all to swing the 3 to the back. So you have the x squared plus x plus 15 And then from here, you find a factor form. However, this one, we cannot find a factor form because the product of two numbers, you can get a 15. When you sum those two, there's no way you get a positive one, right? So that means factor won't be work. So we can use the quadratic formula to solve for this part. So let me erase here. So we go with the quadratic equation. In order to use the quadratic equation, we have to define your A is 3, B is 1, and C is 5. So now we substitute these three numbers into the quadratic formula. So we have 2A negative B plus minus B squared minus 4AC. So you have 4 times 3 times 5. Okay. So now we clean up this number. Plus minus 1 minus 60. So which means you have negative 59 under the radical over 6. With the square root, we don't want to get a negative number under the radical. Remember that? That's on chapter 1, year 1.3. So we rewrite this square root number into the plus minus root 59i divided by 6. So solving the solution of this polynomial function, we have one solution is 2. So we have x equal 2. From this factor form, we find x equal 2. This 3, we use this quadratic formula to find the x is equal negative 1 plus minus root 59. I is outside over 6. So you have 3 solutions. 1, 2, 3. Here is plus minus. Alright, so now the last two questions, they are from your assignment. So we do that real quick. Use the factor theorem to determine whether the statement is true. If the statement is not true, so indicate it. Okay, so x plus 1 is a factor of this polynomial function. So how can I tell it's a factor form or not? We just simply to substitute x equal negative 1. You don't substitute a 1 into it, right? Because this is a factor form. So from the factor form, finding the x term, we set that equals 0. That means x equals negative 1. So now we substitute a negative 1 into it. So we'll have 3 times negative 1 to the power 5 plus 2 multiplied by negative 1 power 2 minus 3. Here you'll get a negative 3 plus 2 minus 3. So this is not equal to 0. So that means x plus 1 is not a factor. Okay, because we didn't get a 0. We have here is negative 4. Use the factor theorem and the syntactic division to determine whether the given polynomial is a factor of the polynomial function p of x. It gives us the function here. It tells us this x plus 3, we are not sure is a factor or not. So we substitute, we do the remainder theorem. So from here, we set x plus 3 equals 0, x equals negative 3. And now, you just substitute the negative 3 back to here. And see whether you can get the 0 or not by the end. If the output is a 0, that means yes, x plus 3 is a factor form of the polynomial p of x. If not, then that is not true. Alright, so you try this one yourself. Just see whether you can get a 0 or not. One more. Use the syntactic division to perform the division. So you have to write down the solution with the quotient plus remainder over the divisor. Okay, so this one, I probably cannot finish this one because the time is almost run out. Alright, let's see. We can use a syntactic division, right? So I just write down the number term 1 by -2, 1, and then -1. Syntactic division, we only take the numerical term. So the divisor here would be -2, not a 2. It's not a positive 2, it's a -2. We set it equal 0. From here, we solve for x equal -2. Now we drop down the first term. Multiply these 2, you get a -2. Sum these 2, you get a 3. Multiply 3 with outside -2, you get a -6. Now you have -8. Multiply these 2, you get a 16. Sum these 2, you get a 17. Multiply with outside -2, you get a -34. So the remainder is -35. Now how do we perform, or how do we interpret the solution here? This is a constant term. This is x term, x squared term, and x3 term. So we write down the quotient. This is a quotient, right? So you have x power 3 plus 3x squared minus 8x plus 17. Then plus your remainder is -35 over the divisor, which is x plus 2. Here you have the double sign. We just change these two signs into the single sign, put a minus in the between. And then that would be the solution to perform the result of this question.